Moet toch wel een smoel krijgen.
Yeah.
Good evening, everyone. Thanks for being here. It's a bit less than expected, so I'm going to throw that on the snow or the strikes, who knows, but we'll make a nice evening from it. Thank you for everybody who's watching online. Tonight we have a presentation from Gerard de Leede from Solarge, who has made lightweight solar panels that we are also exhibiting here. So we're very happy to offer him a spot to tell us a bit more about it at our Innovation Café. For those who haven't been here before, we are a weekly networking event where we offer presentations on the subjects of technology and design. So do check out the presentations for next week, because from today onwards we're here every Thursday. Afterwards we have the opportunities for drinks at the bar, but let's first enjoy the presentation.
Okay, thank you. So I am going to try to take you into our story of the solar modules of Solarge, which are completely different. Are really completely different from existing traditional solar modules. I'll start again.
Zou je ook ietsje meer onder het scherm kunnen staan?
Oké, ja. Oh, inderdaad. You were all hiding. Okay, I'll start again. My name is Gerard de Leede. You missed the introduction, but I'll say that. I am co-founder of the company Solarge, and Solarge makes solar panels in a complete different way. You can, if you didn't see it already, you can have a look at the solar module in the exhibition space at the left side, looking from here, against the wall. And it's explained what I'm going to explain more detailed, but how we make a panel that is circular and that is low carbon and that is very light. So it is completely different, and I'm going to explain it needs to be completely different from the technology as we have it right now. It might be surprising because solar energy is thought to be good, but it's not good enough. This is the factory we found in Weert, and in 4 months from now we will start it up. We will have about 120 people working there, and we will produce 700,000 panels per year. And we're receiving a lot of containers right now, every week a few, and in the end the whole equipment is about 8,000 square meters, 10,000 even. So this is the research labs and the offices that we have in Weert. We are very lucky having found this, although we would have preferred to be in Eindhoven, but hard to find stuff. But most of our technology comes from this area. And, there are drawbacks for solar modules, and maybe the most striking one is the first one, that most roofs, if you look at commercial buildings, about half of the commercial buildings cannot carry the weight of solar modules. And I think here you can see there are empty roofs. There's only one reason: they can't carry regular solar modules because they are too heavy for that roof, because the roofs are designed cheap as possible, and that means now you look into a solar era, it's not possible to cover them with solar panels. Second point, and almost nobody does know that a traditional solar module contains PFAS, fluoropolymers, so to speak, in the backsheet of the white backsheet. If you look at it, a traditional panel. And fluor is really a substance that is, PFAS is really a problem in production. It is hazardous, it is poisonous, but also in getting rid of the panel in the end of life. It's really a hazardous substance, and in fact it doesn't go away because it's so strong, like your cooking pan is also having a layer of fluoropolymer, and even raincoats do have it, and it's a fantastic substance, but it has drawbacks in being poisonous. So our panels don't do that. Of course, the solar panels deliver CO2-free energy, that's nice, but in order to produce them, you need quite a lot of energy, and the energy that you need for it, if you go on the Chinese manufacturing approach, with a lot of coal, and then really you have a lot of CO2, and if we go along the way as we do, so going with exponential more solar panels as we do it today, then by 2030, so that's very close, it's tomorrow, then we will have more CO2 emitted for solar panels than we emit for the complete worldwide aluminum industry. And that's really an emitter of CO2. So let's be cautious with doing that. What it means, by the way, I once computed if we would turn over the whole world with solar panels today, it's not possible, but if we could do that, then you already absorb half of the carbon budget for 1.5 degree Celsius scenario of global warming. So that's a lot, and it matters. So we really should fight it. And by the way, I can assure you that Europe, most of the commissioners in Europe are already seeing this problem and putting different incentives and also punishments on high carbon solar modules. Recycling at the same way, because panels live about 20, 25, 30 years, but most of the modules are designed in a way that you can't recycle them. It's just crushing and getting rid of the crushed material, put it in the asphalt, and somewhere the fluoropolymer is lost. If you are lucky, it's lost in a neat way, and it's put into a separate flow of material and chemical waste. If you don't do it right, you can guess where it ends up. And finally, of course, the cost of solar energy must keep on going down because it needs to be cheaper than it is today, and it can be much cheaper, and a lot of developments are going on. Solarge, I will show you how the solar panel looks, but focuses on actually all the markets. So it is about the commercial buildings, like this one. It is about agricultural buildings, and it is about putting them onto the housing. Of course, the first two, they often have carriage problems, weight problems. The third one, house, it doesn't have a weight problem, but it still has strong demands on low carbon. So there our modules make sense as well. Here it's shown by this woman, happens to be my daughter, that she can carry it with one hand. So it's really a light module. It's half the weight of a regular solar module. And it's shown in these bar graphs. What it means that reducing the weight by a factor of 2, you can go to another 250 square kilometers of rooftops that you can cover in the Netherlands alone. And this problem is worldwide, of rooftops with problems. And if you compute it back to the Groningen gas production and the energy that you create by simply burning gas, then this available area is twice more than the whole national production of last 2021 of the Groningen gas, which is going down anyway, by the way. But so it's really substantial if you finally end up doing this extra rooftop with the panel. The reason for the change of the weight is clear. It's going from glass on the front sheet, you can see it over there, to a few glass fibers. It's a very low weight, and increasing the amount of polymers, but they have to be really smart. And then the cell is exactly the same, so there is really no difference. And of course, also our module doesn't have an aluminum frame, and aluminum again is a real emitter of carbon in the production. A few projects are installed already. The oldest one for 3 years on the right corner, and it's doing the same performance as a regular solar module. So there is not really a performance difference. Of course, these are very interesting, but really now we need to start up the manufacturing in high volumes, 700,000 modules, but we have to have the production machines for that. What is also interesting, maybe due to lack of time, I won't go in detail, but in the wind tunnel in Eindhoven, we tested a system with horizontal mounting, just flat on the roof, and it works fantastically because it's much less wind forces act on the solar module, so it doesn't get picked up by the wind. So you need much less places to fix it to the roof, as you can see in the right in the middle. And that means you can mount it much faster than a traditional module. And the reason that our module can be placed horizontal is because it has no aluminum frame and no dirt can go into the aluminum sides, which normally you have to see a lot of dirt, and the module needs to be lifted by 12, 15 degrees to get off the water with the dirt. In our case, it doesn't matter. So, coming back to the point of how we look at solar panels. In the past we thought it's fantastic. For 50 years we have been thinking that. But now there is a shift in paradigm, and you see that we start to think about the embedded carbon. To make a solar panel you need carbon, I just explained that. And finally we start realizing there's a lot of waste, and now it's going to landfill or road fill. So meaning it's really there, it's not really treated as a returnable product. But it can be, and it's having quite some value, so you can return it and have the value back that you put into it. So this circle, or it's not a circle by the way, is a linear way of thinking. It's addressing how solar modules are being made from sand, really quartz sand, so it's really too custom. I won't go to all the details, but I can tell you that the sand is burnt with wood and coal, and it gives a lot of CO2, and then the sand is purified and getting rid of the oxygen that's in the sand, and you have some metallurgical substance, silicon, as they call it. It's a metal. You need to purify it even more, then you get photovoltaic grade. I hope all of you maybe like this story because it's technical, but really that is also having large emissions of CO2. And then it's molten into what they call ingots, so big poles. I was in the factory in Norway, and it's really big poles, 8 meters long, of that ingot. And then the ingot needs to be sawn into wafers, and the wafer, okay, that's 0.2 millimeter. But to cut it, you have sawing loss, cutting loss, and the cutting loss is enormous. It's 40% is being transferred into powder and thrown away. And then you get the wafers. And then you get the cells, that's another factory usually, and then you come to us because we make panels of it, then they go to the plant, the power plant, and at the end we throw it away. So that is not a good model for long term, especially not with this growth rate. So we checked our panels. Can we, well, it was designed for circularity, can we do it? And the answer is yes, we can do it, and that makes it possible to make a circle round. So you go back at the end of life, and I will go to the detail in a minute. But you can get back the substances, the cell, as well as the plastics, and make a new solar panel. You see the detail of you reheat the panel, and you can take away the plastic sheets from the cell, which stays quite intact, and the cell stays pure, and that means this high purity, you can reuse it in the production of a new cell. If you would know the traditional glass-based modules and with aluminum, they just crush it, everything gets together, and you really have a mix that you cannot use anymore, except putting it in the asphalt. So this is really designed for recyclability, and it's proven already. Now I like to tell you this story. I like it a lot, but I hope it's not too complicated to explain. This is a picture drawn by William McDonough, the founder of cradle-to-cradle thinking in 2003, together with Baumgartner, if I'm correct. And he said in 2015, we need to look at durable carbon. And durable carbon, what is it? This picture tries to show it. If you look at the left corner, then you have fugitive carbon, and it means that you have a very negative approach, because when you have a carbon being burned, as oil or whatever, as gas, then you get, of course, CO2. Or if you make a plastic of it and you throw it in the ocean, you have another problem. The CO2 is in the plastic, but again, it's in the ocean, as dirt and fish and other animals die from it. So that is not the way to go. If you look at the right corner, then we are in our own territory, because we live on We live on carbon. As humans, our bodies are made from carbon. We chew on biological food, either animals or plants, and they contain sugars or fats or whatever, and we transfer them into muscle or fat, whatever. And there you are in the living part of the carbon transition. And so we cannot be mad at carbon because we would be mad at ourselves. But realize there is a big difference between the bad carbon and the good carbon. In the middle, there's an interesting position which nobody really took too much care of, is the durable carbon. You can start recycling products like plastics. It's really a lot of attention and technology development today. And what is interesting, it's not only recycling the plastics for packaging, for example, but also the plastics that are used for our panels. You can do the same recycling method. And then you're in the field of durable carbon. You can do that forever. So once you produce a plastic, you can keep it in the engine forever, of course with some energy, but if you provide the energy from wind or solar, you're not adding more carbon. And our panel itself is already a plastic product, so it produces the energy for that cycle. If you start thinking about that, then there is a transfer or, say, paradigm shift. So if you burn a 160 liter barrel of oil in a diesel car, we can drive to 2,000 kilometers. If we do it to electricity generation, this will give, because the electrical car has a higher efficiency than a fossil fuel burning car, and you can double the kilometers you can drive with this barrel. But if you make 10 panels from the Solarge technology from it, and not burn it, and you have an electric car, in 25 years you can drive 400,000 kilometers. Think about that. So that's, I don't know, 100 times to 200 times more than what you can do if you just burn it. So, and what is interesting, I'll explain in a minute, you can make the modules that we produce also by bio-based or reused recycled plastics, and that is technology that is available. It's a bit more expensive, but it is available. And SABIC, our partner in the plastics, has developed this technology. On the right-hand side, you can have the plastic feedstock being recycled. And by using those plastics from recycled plastics, you save carbon because you are not burning it. And per kilogram of product plastic, you save 2 kilograms of CO2. The left corner is even more interesting from the CO2 perspective because you can put carbon into living plants. And if you rearrange those living plants into polymers, that's technology also existing, then you even save double, so 4 kilograms of CO2 per kilogram of plastic. And this is not something in the air. The only thing is, it's realistic. The only thing is, it's available in limited quantities. But imagine that you can reuse the waste that we produce worldwide, and it goes to this kind of pieces that is ocean-bound plastics, they call this. If we start collecting the ocean-bound plastics, some companies are doing this, and you produce solar panels from this, you don't need the oil, and you can really solve a huge pollution problem that is in many countries that are far away from here. So I see this as a future perspective, because if you organize this, you can do much better than we do today. And by the way, SABIC, our partner, is already arranging for that to get the plastics from that kind of supply chain. So for carbon footprint, I was mentioning in the beginning, you can have a huge reduction, and you can make solar panels almost without a penalty on carbon emission. So that's about 10 times better than the conventional modules. What you need really, if you look at the panel, and you can see the raw materials over there, but I go back in the supply chain even further. For the silicon, that is most of the cell is contained of a lot of silicon, which is a metal. You produce it from very pure sand, and so sand contains silicon and it contains oxygen. If you take away the oxygen, you have the silicon left, but you need it very pure. That's why you start with very pure sand. If you do this very intensive, energy-intensive process with water hydropower in Norway, and at least 2 of those factories are in Norway today. They do, of course, a much better job than doing this in China with forced labor, because there is where the forced labor is, to get rid of, or to get the production of silicon by using the energy source, coal, as an energy source for the electricity that you need. So this is the way to go. It's, again, more expensive, so what are people willing to pay, or where are the penalties that our politicians put on the modules that come from the current supply chains from China? And this is really happening in a few years, or maybe even 1 year. What you need for our panel of 10 kilogram is just, let's say, 2 kilograms of ultra pure sand, and a little bit, and it's over there, is silver, tin, copper. By the way, also a little bit of aluminum back on the cell, but I left it out. But really, we're speaking about grams, 2 kilograms of the sand, 8 kilograms, and of course, you can make the panel, the polymer from our panel, you need 8 kilograms of polymer. So you can make it from oil, and today our first panels that are made from oil transferred into polymers. But I was just showing the process is ready to do it with a recycling method from biological origin, for example, frying fats, and I'm really not talking nonsense, because SABIC has set this up so to get back the frying fats worldwide to make polymers from it and not burn them or dump them. Tar oil, another one is from the paper industry. It's a byproduct, it's a biological source, and you can also produce from tar. Yeah, the word says it is oil, but it's coming from a tree, and the trees that grow on a daily basis. And it is a byproduct from the paper production, so why not use it in the biological route? So that is a real transformation of thinking about raw materials for energy production. And in fact, you go from burning stuff to using stuff and keeping them in the supply chain, as McDonough has shown us with durable carbon. And I end up this small outline with a dream that I have, which is hard because it's a competition with the food supply chain, maybe. This could be the raw material for the polymers, a sugar beet. And a sugar beet, for example, in Brazil, there is a company called Braskem, and they make the polymers that we need, Solarge, purely from sugar beet. Of course, sugar beets, they contain also oxygen and water. It's quite rough to make a good polymer from it, but it can be done. And what is interesting, again, as I pointed out, it absorbs carbon, it grows. It absorbs, by the way, 1% of the sunlight to grow, just 1%. If you transform this beet into a solar module, then at once you have 23-24% of solar absorption in your solar panel being transferred into electrical energy. 1% to 23-25%, and even going higher, because technology of the cells goes up and up and up. So it is my dream. It's not so easy because for SABIC, they are very sensitive to competition with the food supply chain, but I computed for the Netherlands. We had in the past 140,000 hectare of sugar beet production in the 90s. Now we have still 70,000. If we would do all the solar panels that we installed last year from the Netherlands with the sugar beet route, we need only 1/7, so 10,000 hectares of sugar beet. So it's really showing that there is an option, but some laws and some punishments or helping subsidies or CO2 emission needs to be, some system needs to be in place to make this comparative with the regular oil way, but it's going to happen, I think. Need a bit more time. That was my story. Any questions?
What's the price of the solar panels in comparison to existing solar panels?
That's good.
Production cost.
It's a good question. It's the question, of course. And it comes to our business plan. So our introduction price, when we start producing in May, June, is about double the price of the Chinese modules. But if you look at the difference in materials that you saw in one of the graphs, that is so much smaller if you go to high volumes, so millions of solar panels. We already have the prices, of course, from our suppliers, and we know that the price will be similar or even lower because we use less material than the price of Chinese panels. Of course, we need to be having a second, a third factory, and to get into the volume that we need to have that price. Luckily for us, we know that there are so many roofs and the energy is so expensive. The roofs that cannot carry, so our introduction market is the lightweight roof market, where we can ask the double price, but we definitely have a cost roadmap going down by having higher numbers of production. So in the end, that looks good, but it needs 3 to 4 years to walk that roadmap.
The second question I have is the tin and the copper, let's say the base materials that you use for producing these solar panels, are they all available in Europe or in, say, our friendly countries in sufficient amount?
Yeah. The only material, if you look into detail, is a couple of years ago, gallium, which is quite a rare earth metal, so to speak. It was introduced, and that is not highly available in the world, but we have copper mines in, I think, Poland, for example, and really we have enough material to be producing our own stuff in Europe. Of course, there is hesitation to work on these copper mines because they have to compete with other copper mines in the world, but definitely there is enough copper, tin as well. Sorry, I was talking about copper, I meant silver. Silver mines. So there is enough silver, and of course copper as well. And once you get into the curve of growth, you can reuse it. So that's the good news. If you get them back, you don't need more copper and more silver.
And can you also use the old solar panels to put into the recycling process?
Yeah.
Existing solar panels. It doesn't have to be the new solar panels.
Okay, no.
Or the recycling process that you described.
No. Because the existing panels have a different design and they are very uneasy to disassemble. And so the reality is that they are crushed. So they take off the aluminum frame, that's the easy part. They cut off the cables, that's the easy part. And then they crush the rest, and the glass and the plastics and the cells get mixed up. And because it gets mixed up, it's cross-polluting everything, and you can't use it for glass recycling, and you can't because you need ultra-pure glass. And you cannot use it for solar cell recycling because you need ultra-pure silicon.
I would like to ask some general questions. If you could mention one thing that makes you the most proud to be part of Solarge as a company, what would that
be? To be honest, we had a marketing company from the States trying to help us with our message. And I think they summarized very well because their sentence was, we thought of every green thing. I think that's really a very good summary. It's not about one green thing, no pollutants, recyclable. We thought of every green thing. And of course it has a penalty of price in the beginning, but there is a road to market because we can do it through the lightweight roofs. And I'm 63, so I think I can witness that the company can grow internationally. And I will, of course, contribute to that. And that is an answer to your question, I hope. Yeah.
When it comes to the product, it's all about innovation. But it's not just the product, it's the humans who make the product. So how you stimulate that innovative mindset within your employees? Is it something natural, or do you have to engage people to keep innovating the product themselves?
That's a good question. When we started off in Eindhoven, we were with 7, 8 people, and they are really let's say, R&D minded and innovation minded. Now we are in a, so we don't have to push them because they are selected and they are creative. Now we have to hold down, please, because if we keep on inventing new stuff, for example, we had panels at sea already, and if we keep that road, we are really sticking to the development. So now our organization is changing from R&D to production mindset, and we get operators inside, and we need to, luckily we have experience how to operate a plant, so 2-3 people have done that before in large scale in Philip. But it is a challenge to keep that balance, because the product is at the beginning. In fact, SABIC started in 2010 with the developments. We took over in 2018. It's 2023 now, so it took us 5 years to get into a sellable product that can be sold and is certified. And now we have to balance between keeping the innovative mindset on the innovation team and at the same time keep the mindset of doing the same thing every day in production. And I think what is the good news? Quite a lot of engineers are very interested to be part of the Solarge story. We don't know about the operators, but we are selecting them right now because there will be 5 shifts, and that's not always nice. But so far we have some selected operators and maintenance staff, so yeah, we'll have to see.
One last question, if I may. By being here, I think it's important for you to tell your story, share your story with all of us. Some of us are not, are not in the branch, in the sector. Why do you think it's important to be part of this Eindhoven Innovation Café to share your story with everyone who would like to hear?
Yeah, I think also a good question. I think, well, we have a good relation for years, and I think the world of design, which I connect to the Kazerne, is really, of course, we don't make very nice designs, we make technical designs, but the world of design is really addressed by this, and also architects and city planners and so on will need to know about this. And of course, that is not a direct sales approach, it's about advocating what we are doing and that it can be done different. But we do that on various levels like here, but also in politics, in politics in The Hague, to show people in politics that there is a different story that goes along with the solar modules. And that needs to be addressed. And luckily, also Europe is accepting the fact that we need to address the CO2 emissions from solar.
I have a more specific question again. Am I right in understanding that they're currently mainly being used for agricultural companies, right? The solar panels, or are they? So what I'm wondering is, like, in what timeline would it be feasible for regular households to be using these solar panels?
That's also a nice one, because in December we did a energy poverty household together with Minister Jette. He opened the household, but we donated our panels. The weight advantage is not counting there. So people have to be motivated to, in this case, of course, it was donated, but I think private people, we see a lot of response. We were on TV. We see a lot of customers, end customers, consumer response when we do something in the newspaper. So I think 5 to 10% of the people is aware we should make a different choice. But what helps even more, there is, I didn't explain because it's complex, but in our new build demands, so new houses and new offices, there is a very strong demand on the environmental score, which should be low. And our panel was just accepted in that system, so it's officially certified, also in France. And then it has I have been CTO at Heimann, so I know something about building. There is a real reward for having this good score. And the construction designer company can make different choices about heat pumps and how to heat a house in relation to how to generate energy. It's a bit complex to explain, but it's rewarded there, and that's good news, because then it's, of course, the new build market. And, but it's interesting by itself, so we have, of course, good contact with construction companies that have to build new buildings, and turning the knobs how to do it with the best cost, and that works with our panel.
Thank you very much for your presentation. I was wondering if I understood correctly, you can recycle your solar panels. So in the short term, you could be a competitor for the sugar beet market, but in the long term, you will need less and less, I presume. Or how much do you actually lose in the recycling of the product?
Yeah, that's a very difficult question. On the short term, we will not compete with the sugar beet, because it really needs SABIC, who makes the plastics finally, to be using the sugar beet. So that's I cannot convince them, because they have their own policies. But for them, the frying fats is already a route that is developed, so they do that. And the tall oil from trees in paper production is also a route they have. And they told us we do have more than enough to supply you. So that's the good news. But now I missed your question. So it needs much more time to go to the sugar beet route, because we need the supply chain to switch. But the Netherlands, as a country with really agricultural strong history, and with really at this moment at least big problems in agriculture, because we have the nitrogen and ammonia emission issues. There is new, how to say, perspective for this agricultural industry. So they could really contribute to the energy transition. But it's not easy, because the price will be higher in the beginning. But what I'm working on is, some of you might know, there is a carbon credit system for farmers. And if you keep the carbon in the plant or in the ground, you don't emit it, and you get rewards. And this system is different from the carbon emission trading system, which is existing already for big polluters, let's say. But this carbon rewarding system is really interesting to talk to those organizations that offer money to convince a farmer to produce for polymer production rather than for food production. But also, you sense this is really a political issue, and we need more time to let people, also politics and decision makers, start to be aware there is a different route. And that takes 5 years at least, I think.
Third question. How does the Solarge compare in guarantees for electrical performance and for lifetime? How do they compare with conventional solar panels?
That's a good question. I left it out of the presentation because, it's already technical, but we are giving the same guarantee, so 25 years, on the performance. And we have a lot of evidence for that, because with SABIC and others, we did a lot of testing with UV light, which is from the sun, and we simulate the sun over this long period, including the temperature that goes up and down, and the freezing of the panels, because today we have a freezing circumstance. So all that is done, and together with SABIC, which is enormously experienced in polymers for car making, for example, we are sure that we can give the 25-year warranty in Northwest Europe.
Right. Thank you so much.
Welcome.
Thank you for telling your story about Solarge. I warmly invite everyone to the bar in a second, and to carry on talking about it and to get to know each other. For those, you weren't here when I started the introduction, but we are a weekly networking event. So do check out our program for the next couple of weeks. The program is up to date until the end of March, and we'll carry on after that, of course. So in next week, you want to be here, grab someone along with you who you think might like it as well, because we love to grow. But for now, enjoy the evening. We also warmly invite you for a meal at the meetup table for 1950. Tonight that will be a tortello with artichoke. And for the drinks, I will provide some bitterballen, both vegetarian and regular bitterballen. Yeah, let's go and get some drinks.
Right.